So without further ado, let us begin. All right, so just a very brief introduction about me. So I speak at a number of conferences. I used to be a security consultant. I now do mostly R&D for eSentire, and we're a Toronto-based cybersecurity company, but we have offices all over the world. So we're just going to cover what is Cymon. How many of you heard about Cymon before today? I did. Okay. All right, so yeah, so we'll cover what Cymon is, how you can use it, why is it useful for you guys. We'll talk about a bit as well about machine learning, how it comes into play with Cymon, and the architecture of Cymon and cloud applications in general. So very, very quickly and easily, Cymon is essentially a very big aggregator of a bunch of security reports from all over the internet. So there's different sites and companies that provide feeds about malware, phishing, and so on. So all of these feeds essentially get aggregated, pulled together into Cymon, and you basically get the benefit of having everything in one place. Plus, because we have all this data, we can do a lot of different correlation and other interesting stuff about the information we're collecting. So about on average, Cymon ingests about 20,000 new IP addresses that have never been reported before each day. And we have about close to almost 200 different sources, different feeds. Some of them come, for example, VirusTotal would be one feed, PhishTank, and so on. Some antivirus companies have websites that, this microphone is terrible. Some antivirus companies will have a website where you can submit a URL and they'll scan it for you. And if they post those results on a public web page, then Cymon will go out and scrape that too. So a lot of different sources. So very quickly, we have about 4.6, it's probably around 4.7 now, million IP addresses in the database. Cymon started running about early this year. I'm going to say maybe February. So since then, that's the amount of information it's collected. And there's about more than 26 million events. I am going to guess it's about 27 because these numbers from about a week and a half ago. So why build Cymon? What is the reason behind it? So I modeled it based on the needs of our security operations center. In a given day, we get a bunch of different reports and events from security-related devices and so on coming in on the SOC dashboard, and they get an IP. And given that IP, we need to answer three quick questions about this piece of information. First of all, is it malicious? Obviously, that's the most important one. We want to know if we should block the IP address or not. Secondly, what other attacks have been reported on this IP? This could help you determine if this is a one-off incident or this is actually a bad IP address that belongs to a cybercriminal organization. So if you see a lot of stuff coming up on that IP, it's probably something you want to block off forever. Is it me? Let's try this. Whoa. OK, and the last is the network. How many more hosts have been reported on the same, usually C-class subnet? So if I get to see a lot of hosts that got reported on the same /24 network, then that's probably a bad network that I want to stay away from. And this is what Cymon is trying to do very quickly for you. And this is how it's going to look like. So when you punch in an IP address, this is one of the blocks you're going to see on the page. Very quickly, you can see there's malware reports, phishing, and other malicious activities, which include scanning and so on. So let me show you a live example. Where's the mouse cursor? Where's the mouse? Here we go. All right. So this is the event. This is the page for one IP address that was reported. It looks a little funny because it's scaled for mobile device. The resolution is a little small here, but As you saw on the screenshot, you can very quickly see all the information you really need, but most of the value comes from the timeline. So in the timeline, you can actually see what was recently reported and all the way back to when we started collecting information. So back in February, there was a command and control channels reported on this IP. And then Eastern Tire found that as well. And then malware.com and some block lists and so on. So all this information gives you a very detailed view into what really happened along this time on an IP. So as an analyst, this is a great source of information for you to come in and look at what's going on and make a quick determination if you should block it or not. So if you're an analyst or an IT person, a firewall admin, this is hopefully going to help you a lot in your day-to-day job. So let's get back. Okay, maybe I'll switch to the regular microphone, eh? I'm pulling a Z.
Nice.
Just turn it off. Okay, all right. So yeah, this is the events timeline we just saw, and some examples. Now let's look at some cool graphs. So this is the events acquisition graph. So when Cymon started running, we had maybe about 10 to 20 different feeds that were coming into Cymon. And over time, we kept adding more and more sources and improving the system as well. So sometimes we'll get to see spikes in the data acquisition that were caused either because we added a really new source that has a lot of information, like emerging threats, for example, or we optimized the system. It was able to process a lot more events per day. So this is essentially what the big spike is over there. And some of the cool stuff we can do is, like, I want to see all the IP addresses that got the most sources that reported on it. So Fish Tank, the NSBL, some other blacklists, and so on. So this just gives you an idea of what's really bad out there. Or you can also ask the question, which feed provider actually reports on bad APs the soonest? So you can actually have them compete against each other. So the map visualization I showed you, this gets updated about once an hour. You can really see the different regions and where more attacks get reported coming from. We also got the Twitter interface, which is essentially like an API for humans. You can just ask it a question, shoot an IP to it, and it'll reply back to you. Don't try it now. I'm not sure if it's online or not. I'm actually rebuilding it. Well, when I say me, my co-op. I'm lazy. And one of the biggest things is the API. So Cymon is a not-for-profit database, essentially. We're collecting all this information and letting you access it. So the APIs should make it very easy for you to integrate querying our database in your business process. So either like firewalls or your DCs, whatever collects your logs, if you have a SIM or anything like that. So really, it's free. We do throttle requests if you are not logged in. So you'll have a lower rate limit on how many calls you can make. All right, so for the first t-shirt, let's see who can give me an interesting use case for Cymon. Like, in what situations would you want to, like, in mass, check a lot of IP addresses?
Incident response. So you go and you have to log, quickly track the IP.
Absolutely. So incident response, for example, when you collect a lot of logs and you want to start removing stuff that could be non-malicious, and just look at the potentially bad stuff and start filtering those out. So yeah, another example that I'm going to give is, for example, dynamic block list rules. So you can generate your own block list based on the last 24 hours worth of reports and have that feed that into your firewall block list. Another example is, for example, Apache log analysis. So if you want to see like how many bots or bad actors are connecting to your web server, this is an example of a script that I made in like 20 minutes to basically just parse out the IP address portion from the Apache log and just shoot it off using the API, and then just give you a summary of what's bad, which bad IP address is connected to you. And this is something we're going to go into a bit more in depth later, but essentially, who knows what DGA is? Okay. There we go. Yeah, so DGA stands for Domain Generation Algorithm. This is one main technique that malware these days uses to communicate back with the command and control channels. So, because they cannot hard code the IP addresses and the domains because they'll be found by security researchers, so they created a mechanism, an algorithm that essentially generates a predictable domain name based on a certain seed function. Sometimes it's time-based, sometimes it's like some sort of a secret passphrase. But the idea is that once one domain gets blocked, an hour later is a new domain and the malware can connect to it, and researchers can't tell what the next domain is going to be, so you can block it. And all of these are running behind fast flux networks, so even IP addresses are useless. So Cymon, when it ingests data in, and you also have a manual interface, you can, it'll take the domain and actually run it through a machine learning model to essentially give us a prediction how likely this domain to be generated by a human or by a computer. So if we get actually something matches a computer algorithm, then obviously this should be looked at, because domain names are made for humans, not computers. Right? There's really no need to generate domain names for system connecting to each other.
So you transfer the information within the website?
What do you mean?
Can you transfer this information about DGA to websites or firewall?
Well, so there's an API for the DGA, but I haven't exposed it publicly because it does cost a lot more to run machine learning models on Amazon than just query your database. But technically, yeah, there's a way to just shoot off domains to it from like your web sense or something like that and get feedback back. All right, so just for the sake of full disclosure, there are other tools out there. Each one does something a little different. So I'm just going to spend a minute covering them. So UltraEdge is used by financial institutions. It's really mostly a storage engine for reports coming in a taxi format. It's an XML format used to exchange information about threats and indicators of compromise. And it's really unuseful because all it does is just takes data in, but it doesn't have a convenient interface to view it. Plus, there is maybe 2 feed providers out there that support that format. ThreadConnect is a little bit better. It's more like Cymon. You can host it on your own network, but it's closed. You cannot enjoy the benefits of having multiple parties collaborating on the same platform and getting the same insights. ThirdStack is another similar solution, but what they do, the end result of collecting all these feeds, is to generate bro rules for your IDS. And I mean, it's cool, but you can do the same thing with the Cymon APIs. You can pull the data and just construct a rule file for your IDS. And lastly, Mazda by Mozilla is essentially an open source SIM that uses Elasticsearch as the backend. And one of the plugins they added a few months ago was to query the Cymon API. So when you see an API on your dashboard, you can click on it and see what kind of events were recorded on it. All right, so we talked mostly about the threat intelligence portion of IP addresses and domains and hashes. The other aspect of Cymon is monitoring of brands, emails, and so on. So as of yesterday, I'm happy to announce that now this is open to the public. You can, when you register on Cymon's website, you'll be able to, you'll see a link that actually invites you to the preview program. So what it does, Cymon will let you enter a few filters, something like your domain name of your company, your full name, or any brand name that you own. And essentially, it'll look it up on all these sources and give you an alert once a match was found. So a lot of data, and most of the data, is actually coming from Pastebin. As you know, Pastebin is essentially the one spot where the bad guys used to drop off information about coming attacks or the results of attacks. So a lot of times when they compromise a database or a company, they'll post all the dumps they have on Pastebin. For example, Anonymous, when they're planning on doing like a new operation, right? They put a post on Pastebin, basically rallying everyone to go help them. So like OPKKK, for example, has been trending on Pastebin a lot lately.
There's a question about Pastebin that's changed. Every time people can remove data or post other things. So how can your machine work so that the robot come back every time on pages? Or?
Yeah, so the question was because Pastebin, a lot of content gets removed and deleted often. So essentially, there's a script that's running on Amazon's Lambda service that essentially pulls Pastebin every minute. It collects about hundreds of documents every minute and sends everything to an Elasticsearch database. So it all goes in, and you have full access to it. So let's take a second just to give you, if I can, oh, there we go. All right. So it all looks funny now because it's such a small resolution. But so this is the dashboard interface that I just mentioned. And if Dana is going to be fast enough, I'm trying to click on Elasticsearch just to show you. Okay, we'll get back to it while it's loading in the background. So some of the stuff it does, you can enter your DNS. So some of the features are not available yet. You can create filters for anything you want, but DNS monitoring, for example, is not open to the public yet, but it will be soon, so come back. But the idea is that you punch in your domain, and we'll basically query and check the DNS records about every couple of minutes. And if anything changes and it's not authorized, then you'll get an alert. So hopefully, if someone hacks your domain provider and pretends to be you and changes, the name server records to their own DNS, then hopefully you'll get notified before the customer calls and tells you that you're serving malware. And also coming soon is you'll be able to punch in, add your organization's IP addresses. And if any reports about your IP addresses come into the Cymon IP database, then you'll also get an alert. So this is an example of Pastebin. So we monitor our customers' emails and brands and so on. So for example, this is email and password leak page. So one of our clients' names was on that page. Let's see now if I can. It's Rogers. Okay, we'll get back to it. All right, so this is what I like to call a passive pen test. So that's a Pastebin of someone that posted 1,000 different websites with SQL injections and the actual injection on the page. One of our customers was on it. So here you go, pen test. You have SQL injection, fix it. But some of the things that get posted on Pastebin, and you probably want to keep an eye on it. So here's a screenshot of the dashboard I was trying to show you, and that's how it's going to look like on your desktop. And that's how it's going to look like on your phone. All right. All right, so come get me after the talk and the hall, and I'll show you how it works. So let's touch a bit on machine learning. And machine learning is the biggest thing. And Cymon employs machine learning for a few things, like detecting domain generation algorithms and creating a security prediction score. So this is not a threat score. It's more like a prediction of how likely an IP is going to be malicious. So essentially, it works very, very simply. For machine learning, you have to extract a number of data points about what you're asking. So in machine learning, it's called features. So you send all these features essentially to the machine learning model that you created, and you're supposed to get a prediction back. Predictions vary between 0 and 1. So 0.7 would be, relatively okay, but 0.95 will be like a very strong prediction. So let's just do a very quick introduction to machine learning to those of you who haven't touched the subject yet. So to create a reliable model, you need a lot of data to throw at it so the machine can see the patterns in the data. But that's the beauty of it. Once you have enough data, the computer kind of figures it out on its own. And that's the real magic behind it. But to create the initial data set, that's a lot of work. You need to sanitize and make sure that everything is actually accurate. You could be throwing too much data at it to confuse the model. There's a lot of gotchas when you create the model. But once you have the model, the results are pretty amazing. So in order to create a model, which is called training, there are two main approaches to doing that. One of them is a supervised method, which basically means I'm giving, think of it as an Excel sheet. I have a number of columns that have all my data, and the last column will basically be the prediction. Rather, not the prediction, but what I know the truth is. So let's use if the AP is malicious as an example. So I'll throw a bunch of data in different columns, and the last column would be, yes, this is malicious. Next row is going to be, no, this is not malicious. So if you have a lot of data, the computer is going to basically learn a lot faster, and it's going to start giving you predictions. The other approach, unsupervised, essentially means you're not giving the last column that says if this is bad or not. You're basically telling the computer, here you go, start finding patterns in the data for me. So it'll start giving you alerts when there's different outliers and exceptions in a data set that could prove interesting. So really, that's the basics of machine learning. It gets a lot more complicated, obviously, but this is what you need to know. So let's run through the example of how to create a model for detecting domain generation algorithms. So this is a simplified approach, but it still stands. So our starting point is a domain name. So I've given two examples of two different domain names. The human brain is amazing. You can easily tell what's good and what's bad, but for the machine, it actually takes a little bit of practice. So the first thing we need to do after we get the domain name is to strip the top-level domain, because really the top-level domain has no bearing on whether the domain was generated by an algorithm or not, right? So all we care about is the root domain. Any guesses why we don't care about the subdomains? What's that? Well, close. The thing is with domains is that the root domain is always going to stay the same. So really, that's what we care about. The subdomains can be generated and replaced. That's really where the data is at. Right, so now that we remove that, we have to start extracting features, which basically means the data points in our columns for the Excel sheet. So let's see, don't forget there's t-shirts. Who can give me ideas of what kind of data points can we extract from the domain? So we have now the domain string, no top-level domain. What kind of data points can you extract from it? What would you feed the machine learning if you want to teach it about bad domains? Yeah. All right, so that's one of the points. So he mentioned basically trying to recognize or find words within the string. Yeah?
Examining
entropy of the string, perfect. Another one, anyone else? Yeah?
Maybe fake websites which domain name closed in order.
I know, okay, I see what you're saying. Close, and what we're looking for is gibberish. So for example, if there's words that don't make any sense and that kind of stuff. So basically, I'm using what Johnny said, so I'm trying to extract words, and then I'm sending it off to another function to figure out if this is a real word or not. Yeah? Yeah, signs to see if it's if it's something that a human can read or not, right? Yeah, so it's very similar to trying to extract words. So definitely. The length of the string has a bearing, the entropy, how many words exist in it, so that's what Johnny said. The mean word length, I found that has a lot of bearings. So, we'll extract all the words and try to figure out, what is the mean length for each individual word, the median, and what the probability is of, these words actually being actual intelligible words, or is it just gibberish? And eventually, and lastly, is the domain name itself. I'm also providing that to the machine learning because I want the computer to also look at that to find patterns in the data. So, all right. So now we know what kind of, yeah, go ahead.
Question. Actually, just bring out the point that you're only taking the main domain, you're removing the .ca. What's going to happen when you're dealing with the domain that is actually that like .qc.ca? Because actually, if you're checking like some of the domain that we have in Quebec, you have some domain that is like something.qc.ca. So
yeah.
You're gonna
yeah, no, for sure. Yeah, and so that's a very good question. So he was asking what happens if you have like a lot of countries and regions have like, 2 top-level domains, essentially. So I'm using a library, I forget the name of, it's a Python library that essentially all you have to do is send it the domain name, and there's a function that basically asks you, that you ask it to remove the top level, and it takes that into account, the 2 ones. So yeah, why build something when, there's libraries out there that do it for me? But yeah, that's a very good point. Yeah?
You see the new DNS dealing system with localized characters for country?
It's a very good question. You're talking about the internationalization, right? Using Unicode in the URL string. Yeah, I'm not supporting that yet. For 2 reasons. It's a lot of work and not a lot of people use it. So, I mean, it's an economy, right? I'm only going to build it if it makes sense. And if it's not, well, then I'll just get a co-op. All right, so let's go through how to build. Yeah, go ahead. So in order to actually generate, in order to extract words from the string, from the domain name, what I had to do, I had to actually generate like a binary tree model that I used a dictionary to build out of. So essentially I took a dictionary of a lot of different words and threw it into a function that built a binary tree, basically trying to find the probability of English words and their lengths and so on. So I'm just throwing that back to the model I have, and then I can extract words based on probability using that. So it's a very simple function. If you're interested in that, let me know, and I can show you, give you a link on GitHub to a project that does that.
What I was saying is that a lot of the names are from surnames or family in the telephone.
Okay, that's a good point. But to be honest, I haven't seen too many of those. So right now the model is pretty accurate. It's about 97% accurate, which is pretty good for machine learning. So we can do another one, try to throw that into the training model and see what the end result is going to be. But creating a machine learning model is essentially trial and error. You create the initial data set, check the model, and then the way it works is when you have the final data set. So about 70% of it, all the data you have, goes into training the model, and then the rest, 30% that's left, is used to validate that the model is actually accurate. So I'll try that next time. It's a good, interesting point. Right. I just want to take you through how to create the data set, though, and that's the difficult part. So keeping in mind the domain generation algorithm as an example, here's how I went about it. So we need to basically, because we're going to use a supervised learning approach, I want to tell the computer, I know this is bad, I know this is good. So I need to essentially get 2 big sets of data of known good domains and known bad domains, right? So these are the 2 sources I used for the good, the Alexa top 1 million domains and Netcraft. So take all of those in together and you got like about 1.5 million known good domain names. And then to generate the bad known domain names, I went to different feeds and I collected a bunch of there's special trackers for domain generation algorithms, and eCentire has our own feed, so I also took that and combined it together. And then you have to run this data through a function to basically extract the features you want that we mentioned earlier, the data points from the domain. So that script works, and then we get essentially a CSV file in the end. So the next step would be to randomize this data. So we want to try to avoid any bias in the data. So we'll randomize it, and then essentially shoot it off to the machine learning function, and it's going to take it in and create a model. And eventually, after it does all the testing, it'll give you the prediction score. But really, that's all it took me to create my model, the models for the machine learning. All right. Any questions? Yeah.
If an API direct get packets for some reason, anyway, and Cymon get whitelist, or can it really these virtual level at some point?
So you're talking about whitelisting for IP addresses. So.
Yeah, if you get a bad luck and your IP get blacklisted.
Oh, I see what you're saying. What happens if you got in? Yeah, if your IP shows up on Cymon? All right. So I get that question a lot. So Cymon is really initially was built as a research tool. So the idea is that it collects all these IP addresses and they stay there for historical purposes, for research. I had a few times, people send emails and asking to remove their IP address. Hey, our host got hacked, but we changed hosting company and IT guys, and please remove us. It's like, sorry, guys, that's not what the tool is all about. So if you use the APIs to generate a block list, for example, a blacklist to feed to your firewall, what I suggest is limit the search history to 2 days or 1 day. That way, you only get the fresh stuff instead of looking stuff for like 6 months ago. All right. So let's talk a bit about the architecture. So Cymon is entirely a cloud-based application. A lot of times people ask me if I'm going to release the source code for Cymon. And you know what? I would, but Cymon is not just one application. It's actually a bunch of small pieces running on Amazon. So we have you guys heard about AWS Lambda, for example? So it's an excellent service. All you have to do is essentially write your code in Python or Node or something, and just send Amazon your code, and they'll worry about the computing infrastructure. You don't have to worry about scaling, resources, concurrency, all that stuff. Just ship your code and they'll run it. And you basically tell Amazon, I want you to run this code when this file gets created, or when this database row gets added, or on a schedule basis. So a lot of these components, that's how they run. Now, for the data layer, we're using multiple different technologies. So there's Redis, there's Amazon RDS, which is basically your relational database. So I'm using MySQL and Aurora, which is their own technology. And there's DynamoDB, which is a NoSQL store. And finally, Elasticsearch for all the stuff that gets posted on the internet. So the idea is, I want you guys to be able to come into Cymon, just punch in like your name or your company name, and just like in under a second, get all the results back. And that's where Elasticsearch really shines. So some of the benefits, if you guys never got exposed to cloud architecture, is that you can scale very quickly. If you guys are going to start sending like 1 million API requests to Cymon, it's going to detect it. Amazon is automatically going to see the influx of traffic and spin up more instances to handle the traffic. And I don't have to do anything. You just basically have to define the rules. I want another machine spun up if CPU is above 90%, or if my traffic usage, I'm getting more than 60 megabytes per minute in incoming or outgoing traffic. High availability is also a great feature. You can deploy your application very easily with the click of a button sometimes to multiple regions, which means you have instant failover. The biggest headache for me is I don't want to maintain databases. Something crashes, you have to maintain backups, restore it. It's such a big headache. And for example, the Amazon RDS service does everything on its own. And if it crashes and it detects a crash, then it'll just restore it to the most recent snapshot. It'll do failover and all that stuff. So really great. If I have a development or production environment, for example, I can very quickly just there's an option in Amazon to actually duplicate this environment. So now I have a second staging if I want to release a new feature and I need to test it. One of the last thing is, a lot of people say that the cloud is bad for security. There's no security on the cloud. And I just want you to know that Amazon's got the most robust logging I've ever seen. You can see when anything small happens on your AWS account. When a machine gets spun up, a connection drops, someone kills something off, someone uploads a new function, a new code, all that stuff, highly detailed, much better than any government, well, maybe that's a bad example, but any private organization. And of course, cost savings. You can start small, so Cymon started very small, and I'm adding resources as needed when it grows. Really, there are two main components. There's the worker tier. You can't see it very well, but there's the data tier that connects everything. We have the workers that do all the processing. They ingest the feeds, they analyze them, do different checks, and save them to the database. And then the web application itself, which in this case runs on Elastic Beanstalk. It's a service that Amazon provides. This is a Django-based application just for the web stuff and API. And the system, again, scales up on its own. So let me show you very quickly some of this, how the worker works. So the machine wakes up, it connects to S3 to download the configurations like database passwords and so on. Then it'll connect to a central queue system. So if you want to have multiple machines doing different types of work, but all reporting back together, you need to have some sort of a queuing system. So it'll pull the most recent job from the queue, do the processing, save the results to the database, and essentially connect back to the queue to pull the next job. So this is pretty much how the worker does all its fancy stuff. Very easy, but also because we broke down all these components, it's also highly scalable. There's an open source project that we're working on. It's almost done, but I encourage you guys, if you want, please fork it and add your own contributions. But this is a Chrome plugin that works like ad block. The idea is that if you go to a website that got compromised and got reported on Cymon the last day, then this plugin will block the website. Now, it comes very useful. Sometimes you'll go to The Economist. Who here visits The Economist? Okay, not that many of you, but I'm guessing you're just shy. So if you guys know, last week, The Economist was serving malware because they had third-party applications loaded on the page, and one of them got compromised. So if that ever happens, and Cymon gets a report on that, then Cymon will be able to block only that offending IP address rather than the entire website. So please, help us. Something else that is coming soon is integration with ThreadLab. So that's a very quick, small tool that I built recently. It's essentially a highly scalable packet analysis system. You can upload PCAPs on that website, and it'll run it through multiple IDS systems like Suricata and Snort and so on. But because you upload the PCAP and I get the public IP address of whoever attacked you and the time of when that happened, I can actually generate a feed and then send it back to Cymon. So again, help the community, keep it growing, and keep the data accurate. We're almost done. Last slide, I just want to ask you, if you guys have time and you're interested in open source projects, there's a few things that we can help for Cymon to build. So if you want to create a Firefox plugin that does something like the Cymon Interceptor, or if you want to create a Maltego transform. So if you guys used Maltego for open source intelligence gathering, right? So you can give, bring in an IP address, for example, And then if you create a transform using Cymon, you can actually see what other domain names, for example, were associated with that IP. So then you can also scale down and see all the trees that belong to the different domains. And just some ideas for you guys. So help us. And that brings me to the end. Thank you guys very much. I'll be happy to take some questions. And I have a bunch of t-shirts for you guys. Please, if you have a good question, try to be between medium and large, because we don't have any other sizes. But I also have 2 lockpick sets to raffle. So, yeah.
From the technology stack,
So Amazon has what's called Amazon ML, machine learning. So I'm actually using that. So it's a great tool for bootstrapping, for creating a very quick machine learning model and connecting it via API to send requests and get predictions. So that's what I'm using for the machine learning stuff. If I get any discounts for the IO domain? No, I wish. But it's a cool domain, right? But it's pretty expensive. Yeah. So yes, one of the feeds is from the HoneyNet network. They have page that lists a lot of like forum spammers and email spammers and that kind of stuff. So that's one of the feeds that goes into Cymon. Sorry, to have what? Like to see the IP addresses, like where they're originating from? So I'm doing that with the map. I don't know if you had a chance to see it, but I'm taking a risk refreshing the page. But essentially, this is our region right now. And you can see like where all these IPs got reported from. Is that what you mean? Okay, come catch me after, and I'll try to get that free. Yeah.
Everything we see currently based on IPv4. Is it something with IPv6 coming on? Or
so the question was, do we support essentially IP version 6? And the answer is yes, but none of the feeds I'm connecting to support IP version 6. So, so I mean, Cymon is ready, but no one else is reporting on it. So, yeah. So I'm not logged into Amazon, otherwise I'd show you the dashboard. If you're interested, come get me after, I'll show you. But the accuracy was measured at 97% for that model. Yeah. So, when Microsoft was the first to actually offer machine learning as a service, and I was actually planning on using them, but about a month or 2 afterwards, Amazon made the announcement, and because I'm heavily invested in Amazon, and honestly, they're the biggest, cheapest, and got the most services, I'm just using Amazon. But fair enough.
Well, the malware that you're seeing, that you can figure out a little bit the pattern of the malware. Is it, and Simon, can you see like how a malware can move a little bit around? Like, so you have a specific malware that you want to know exactly that from where it's coming at. So you can see sometimes the malware is coming from, an example, from China. But is it possible to see that the malware actually, like the signatures evolving and starting to move around a little bit the world? Figure out if you get attacked from one specific country, if you can start it to get attacked from multiple.
It's difficult because not everyone reports malware hashes, for example. So the sites that do, I collect the hashes that gets reported, but also the fuzzy hashing. What's it called? Someone said it. Yeah, SSD. There you go. So essentially, which helps you identify families. So if the feeds will report it, then you should be able to do that. but not everyone does it. Sometimes they'll just report, here's the name of the file, the family of the malware, in human readable stuff, and the IP address. It really depends on the source. So that's why Cymon has to be very flexible to be able to support all these different formats. So, yep.
How can you know if IP address has malware or something else?
It's just, I don't make any judgment calls. Basically, if the feed tells me, so there's different feeds. Feeds about malware, feeds about phishing. So if the malware feed specifically says, this is the IP that malware tried to connect to or malware was served from, then it'll get logged appropriately. Sometimes there'll be more contextual information like the file name and so on. Someone's trying to get to my house. Yeah, did I answer that? Okay. No, I'm not collecting ASN information. I was thinking about it to also be able to do like IP trees. But right now, if you go to an IP page, you'll see the IP who is and the ASN information, but I'm not collecting it to the database, so you can't do that, unfortunately. Maybe in the future. Yeah.
Can people participate, like giving you some IP address, some malware, servers?
So if you guys have your own feeds that is generated by whatever source it is, by all means, let me know and I'll add your feed to Cymon. I'm eventually going to create a page that lets people ask or participate. But right now, yeah, let's shoot me an email and I'll be happy to add it. And obviously, a link to if you have information page or a website, I'll put a link with the report itself. Yeah. So if you are a regular public user that don't pay anything, then all you get is basically all these public sources. So we're talking about 180 something of them. I am collecting Emerging Threats Pro feed as well, but because it's a paid feed and the licensing terms don't let me disseminate it, so it's only accessible for my company. But we're looking at the opportunity down the road where you can, pay for an account and get all these like professional feeds plus the open source ones in one spot. So that's, could be a monetization idea for down the road. But the free stuff is always going to remain, free, available for everyone. Yeah. So, So, right now we don't have customers, but yeah, some of the correlation goes into, like, for example, collecting the different domains that could be associated with an IP address. So I'm getting a bunch of these reports, and this guy is saying this domain with this IP sent me malware, and then this guy said, the same IP but a different domain gave me this. So like all of that stuff will get basically aggregated and collected nicely. And we'll do some bit of correlation, and some of the correlation goes into also determining which feeds are better and so on. But yeah, working with this much data requires a lot of work, a lot of effort, and specialized tools. But we'll hopefully get to do more and more cool correlation stuff. Yeah. Good question. Yes, those of you who had interesting questions for me, come collect your T-shirts and we'll figure out how to do this. I think I'm going to throw this in the air and see who grabs it. So that's the fairest approach I can think of. Yeah, exactly. Fight for it. All right. Yeah.
I just have a FYI for you. While I was researching Cymon,
Yeah.
Cymon is on the blog list for Bitdefender.
Bitdefender? Did they put a reason why?
Just for your information.
Well, there was never any malware that got sent from Cymon. There was never any spam, so I don't know. I hope I'm not ingesting their feeds. Okay, that's a good point. I'll look into it. If anyone works with Bitdefender, come talk to me. Yeah.
Checking that the feeds that you bring in are accurate and they come from
It's a good question. Yeah, so there's a big problem with trusting third-party sources, and not all of them actually do rigorous validation on the data that they're posting. So in a lot of cases, a bad guy is going to have a domain name and is going to use it, abuse it, and then throw it away. And when he's done, he's basically going to change the DNS record of that domain name to be like 8.8.8.8. Which is the Google DNS system, right? So yeah, sometimes, because they'll do like a DNS lookup, and then they'll say, oh, 888, so they'll attach that in the report with the domain. And then there you go, Google is sending malware. But, so that's the problem. And in this case, Cymon still takes this data in. You'll be, for the, right now it's up to you to recognize it and remove it from the data set. In the very near future, with the introduction of the security threat prediction and whitelisting, I'm going to be able to remove those from specific API calls like the blacklist API call. So there is, if you are an anonymous user, like if you're not authenticating, then yes, there's a throttle. I'm throttling you for, I think, like 100 requests or so per day. But if you register, you'll get a lot more. So, yeah.
Are there specific ICANN registrars that have propensity to have more?
It's an interesting question. No, I didn't notice. I mean, it'll be interesting to actually do this type of analysis. Yeah, I'll give it to one of my guys, maybe our threat intelligence team. But yeah, what I do see sometimes very interesting when I look at the Google Analytics dashboard, sometimes when there's like new breakouts of stuff on the internet, I'll see like a lot of people querying the same domain or the same IP over and over from like different parts in the world. So I'm thinking of maybe taking this data and using that as like a trend to feed that back in to people when they come to the homepage, so they'll be able to like be aware of this stuff. But all right, so come collect your t-shirts.